Okay, so here we are. We were just talking about how happiness and income, they always say money can't buy you happiness, but is it true? And it appears not. It appears that if you have more money, you're in the very happy category. If you have less money, you're more likely to be in the not happy category. So we always expect a certain amount of variability between categories. How can we be more certain that income and happiness are not independent? We could conduct a hypothesis test, right? Something called perhaps the chi-square test for independence. Yes. All right. So how does the chi-square test for independence work? Well, remember from section 5.3 that events are independent if the probability of A and B is equal to the probability of A times the probability of B. So how does that work out in a table? Well, what happens is you get your row total times your column total and divided by your total sample size. And that'll be how much should be in each category. And you're totally going to want Excel to help you with this. So let me go, oopsie, wrong spreadsheet. There we go. Hold on. There it is. Okay, so let's do this. This was observed right here. Oops, right up here. This conditional thing was just for fun. So I'm just going to label it conditional distribution. Just to remind you, that's where that came from. That was from way back in the day. Okay, so now I want to be able to come up with the observed and the expected. So let me just label this just a little bit. This column, or excuse me, this table right here is what we actually observed. And then what we expected, I'm going to put right below it. I know I could put it over to the right, but that I want that space for later for when I have to do the test. So I'm just going to move the conditional thing down because the conditional is not that important. So I'm going to merge and I'm going to call this expected. Okay, so let me copy and paste these values in. I really don't want all of them, but that's all right. Okay, so clean slate. All right, now how do you get each one of them? You take equals this row total, which would be 290, times this column total, which would be 168, and you divide it by this grand total, 1362, and that never changes, so you give that dollar signs, the 1362. All right, so then let's drag it to the right and see what happens. Nope, didn't work. Why not? Oh, because it dragged that 290. Well, we don't want that 290 over there. So here. There we go. And then let's do it again. Oopsie. Oh, no. There we go. I want E4. There we go. We got all of them. Do it again now. Equals this 646 times 168 divided by 1362. Now the 1362 gets dollar signs, and quite frankly, so does the E5. If I give that dollar signs, then I won't have the problem that I had on the last one. Then drag it across. There we go. And I'm going to do it again for the last one. Equals 426, give it dollar signs, times 168, divided by that grand total. Give that one dollar signs as well. And there you go. And the total parts aren't really needed. They're not used at all, so we don't need that part. Okay, they're gone now. All right, so we've got our list of expected. So we found it by taking each row total times each column total and dividing it by the grand total, and that'll give us these values right here. So if this function was, if these two variables, row and column variables, i.e. happiness and money, if they were truly independent, then this would be your expectation right here. And of course, we're going to use that to conduct a hypothesis test, and that chi-square statistic should look very familiar to you because it's very much the same one that you used for goodness of fit, but it's just a slightly different way to get the expected values here. For goodness of fit, you're only working with one column, right? And one column of observed values and then another column of expected. For down here, you're working with a two-way table, right? So you've got a column and a row, and that's what makes them different.